Okay, one last trick for sines and cosines, and that is sometimes the sines and cosines are slightly hidden. The tangent of x dx. Now you know how to take the derivative of tangent. The derivative of tangent is secant squared, but whose derivative is the tangent of x? Well, one of the tricks for using sines and cosines is to turn things into sines and cosines. You know that the tangent of x is sine of x over the cosine of x. Aha! And now you have sines and cosines to various powers. You have sine to the 1 power, cosine to the negative 1 power. Doesn't matter. You have one of them is to the 1 power. You can do u substitution. Set u equal to the one that's not to the 1 power. Du is negative sine of x dx. So negative du is sine of x dx, which is our numerator. So this turns into, put the negative out front, sine of x dx is du. 1 over cosine is 1 over u. And hopefully you're not thinking that you'll raise the exponent by 1. Hopefully you immediately say, oh my goodness, this is negative the natural log of the absolute value of u plus c, which is negative the natural log of the absolute value of cosine of x plus c. And I think that is a perfectly lovely answer. However, if you look it up in the back of a book, you're going to find a different answer. Why? Because what they do is they say this is negative 1 times the natural log of the absolute value of cosine of x plus c. And remember, if you had an exponent up here, you could bring it out front. If it's out front, you could bring it up. That is the same thing as the natural log of the absolute value of cosine of x to the negative 1 power plus c. And cosine of x to the negative 1 power, this is an arc cosine, this is 1 over cosine. Natural log absolute value 1 over cosine of x plus c. And 1 over cosine is the secant. So this is the natural log of the absolute value of secant of x plus c. This is where things get a little bit tricky in calculus. These are both right. They're not only both right, they're exactly the same, but they don't necessarily look the same. One of them requires one more mark, requires a negative sign. And so the mathematicians say, whoa, this one uses fewer symbols to represent. We'll go with that one. And we could just check. The derivative of the natural log of secant of x plus c is what? The derivative of natural log of anything is 1 over that thing, secant x, and times the derivative of what's inside, and the derivative of what's inside is derivative of secant is secant x tangent x, and the derivative of c is nothing, and the secants cancel out, resulting in nothing but tangent, which is what we wanted. Bang! If you take the derivative of this, you get the same thing. Oh, you want to do that? Why not? The derivative of negative the natural log of the absolute value of cosine of x plus c is what? Leave the negative, the constant out front. The derivative of natural log of anything is 1 over that thing times the derivative of what's inside. The derivative of cosine is negative sine of x, and the negatives cancel out. Die. And you are left with sine of x over cosine of x, also known as tangent of x, also known as what we wanted. So this is just another trick. Another trick to solving some integrals is try putting it in terms of sines and cosines and see if that gets you something that we know how to solve.